Let's execute some commands to compile our source files. Now head over to the folder that is our workspace under which we have kept our source files, isn't it? We have got ld.c, ld.h, main.c, and main.h. Main.c and ld.c are our source files. First, let's compile main.c. For that, we have to invoke the cross compiler. The cross compiler is arm none abi gcc. Then let's give the input file, that is main.c. After that, let's mention the output file by using the compiler argument -o, which instructs the compiler to generate an output file. Let's give the output file name main.o. This command, what it does is it takes the input file main.c and creates the relocatable object file. But the default behavior of this command is to compile, assemble, and link. But we don't want to link, we just want to compile. So we just want to compile main.c and we want to generate the relocatable object file. If your goal is just to compile, then you have to instruct the compiler explicitly. That we do by mentioning another compiler argument. You can give that compiler argument before you mention the input files. I mean, it's not mandatory, but you can do that. It's better to give the compiler argument before mentioning the input source files. I would give the compiler argument -c. This instructs the compiler to just compile and assemble and not to link. All these compiler arguments you can explore by going through the documentation, that is using a new compiler collection documentation. The link to this online documentation I have given in the resource section. You can just explore. Here, just click on options controlling the kind of output. If you browse this document, you will get -c. Compile or assemble the source files, but do not link. The linking stage simply is not done. The ultimate output is in the form of an object file for each source file. By default, the object file name for a source file is made by replacing the suffix .c, .i, or .s with .o. Let's go back and hit enter. So the compilation didn't go well. There is a problem with the assembler. Now let's analyze this error. What's the goal of this command? The goal of this command is to generate main.o file, that is relocatable object code, which is nothing but collection of machine codes. The main.c will go through all these phases. When it reached assembler, there was a problem. The assembler couldn't able to generate a machine level instructions. So these codes are there in our source file, isn't it, in the form of inline assembly code. The error says that the compiler couldn't able to understand those inline assembly codes. That's because in this command we have not informed the compiler about our processor architecture. That is very important because this cross compiler can generate instructions for various processor architectures like Cortex M4, Cortex M0, ARM9, ARM7. For various processor architectures, you can use this compiler. In our case, the processor is ARM Cortex M4, and either you have to tell the processor name or you have to mention the processor architecture. That we can do by using some more compiler options or arguments. Let's go back to our documentation, and now let's explore about machine dependent options here. You can see that GCC supports all these machine options. and we should be looking at ARM options. Here, just search for machine architecture. It supports various architectures, but the default one, I'm not sure. If you don't supply this argument, I don't know what it takes by default. That's why it's very important that you should initialize this argument to ARM v7, which is true in our case. Our ARM Cortex M4 processor is designed based on ARM v7 architecture. If you are not sure about the architecture, then don't worry, go to another option here that is called as MCPU. Here it is, MCPU. This option you can mention. The arguments for this option is same as mtune. You can pick one option among these various options. You can see that it has Cortex A76, Cortex M0. If you are using Cortex M0 Plus, then you should be using this, Cortex M1, M3, M4. Let's say what it says. This specifies the name of the target ARM processor. GCC uses this name to derive the name of the target ARM architecture and the ARM processor type for which to tune for performance. Let's use this option, MCPU. Let me go back, clear this. Let me mention here hyphen MCPU is equal to Cortex hyphen M4. This mentions the target processor. After that, so one more compiler argument you have to use, that is mthumb. There are two options, mthumb and marm. In our case, we have to use mthumb. If you don't use this, then marm will be considered by default. What this does, this helps the compiler to make a selection between generating code that executes in ARM and thumb states. Remember that the Cortex M processors, they support only thumb state. That means they execute those instructions which are there in thumb instruction set architecture. If you make a thumb processor to execute ARM instruction, then there will be an exception. There are some processors which support both ARM and thumb state. You can switch between ARM and thumb state, but that is not possible in ARM Cortex MX processors because these processors support only one state, that is thumb instruction state. That's the reason you should use this option. Otherwise, GCC will include instructions from ARM instruction set architecture which our processor will not be able to execute. That's why you can see here the default for most configurations is to generate code that executes in ARM state. So we have to override this. That's the reason we should use mthumb here. Let's go back and give mthumb. This much is sufficient for a time being. Later we can explore some more compiler arguments. Let's hit enter. The compilation went well, and here you can see that the main.o is created. This is just a compilation. There is no linking. As I said, we have stopped linking by using -c. If you just want to create assembly file, that means if you want to stop compilation at this stage, instead of -c, you can use -S. Let's explore that. So here it is. Stop after the stage of compilation proper. Do not assemble. The output is in the form of an assembler code file for each non-assembler input file. What you have to do is you have to give output file name as main.s and hit enter. This command generated assembly file for the .c file. That's it. Here it is, main.s. Let's explore this file. You can open in a notepad, no problem. And here you can see that this is a assembly level mnemonics which are generated for our .c file. These are the thumb instructions which are generated by the compiler. So you just learned how to invoke the cross compiler with few arguments to create the object file for your .c file. In the next lecture, let's see how to write a make file and automate this process, because every time, invoking the compiler and mentioning the arguments, mentioning input files, output files, it would be a tedious process. That's why it would be good if we create a make file and automate the build. I will teach you that in the next video.